I want to find the limit as x approaches infinity of sine of x over x. We know that sine is between 1 and negative 1. And so if I divide everything by x, I get negative 1 over x less than or equal to sine of x over x less than or equal to 1 over x. So if I take the limit as x approaches infinity, negative 1 over x is going to go to 0. And now I'm going to have limit as x approaches infinity of sine x over x. And I'm going to also take the limit as x approaches infinity of 1 over x. And that again is 0. So the limit as x approaches infinity of sine x over x is between 0 and 0. And so by the squeeze theorem, the limit has to be 0, since it's bounded by two functions whose limit goes to 0. Okay, next we'll be looking at cosine. So if I have limit as x approaches infinity of 2 minus cosine x over x plus 3. So the first thing we should consider is that cosine, just like sine, is between negative 1 and 1. And if I multiply everything by negative 1, I get 1. The inequality switches since we're multiplying by negative. And now negative cosine is between negative 1 and 1. The next thing we need is to have a 2. So I'm working in order here. So I got the cosine, I got the negative. So the next thing is to get a 2. And that means I should add a 2 to all three sides. So if I add a 2, I get 3 greater than or equal to 2 minus cosine x greater than or equal to 1. Now the last piece I need is the x plus 3. So I'm going to divide everything by x plus 3. So take the limit now of everything. We know the limit as x approaches infinity of 3 over x plus 3 goes to 0. And we want to find the limit of 2 minus cosine x over x plus 3. And we also know the limit as x approaches infinity for 1 over x plus 3 is also 0. So 2 minus cosine x over x plus 3 is bounded by two functions whose limit goes to 0. So by the squeeze theorem, the limit has to be 0. Okay. Let's do another one. I have limit as x approaches infinity of cosine squared 2x over 3 minus 2x. Okay. So the first place I'm going to start is noticing that I don't have cosine. I have cosine 2x first. Okay, so let's start with cosine 2x. So just like cosine of x, cosine 2x is between negative 1 and 1. The next piece I need is a squared. So let's square everything. So this one, it's tricky because if we know that cosine 2x goes between negative 1 and 1, so it looks something like this. So if I square everything, this negative part right here will end up being positive. So that'll be up somewhere here, let's say. And so my range now is going to be between 0 and 1 for cosine squared. So cosine squared 2x will have to be between 0 and 1. Okay, and so the top of the fraction is satisfied. And now all that's left to do is to divide by 3 minus 2x. So let's write that. So I have 0 is less than or equal to cosine squared 2x less than or equal to 1. I'm going to divide everything by 3 minus 2x. So 0 is 0 over 3 minus 2x less than or equal to cosine squared 2x over 3 minus 2x less than or equal to 1 over 3 minus 2x. Okay, and now if I take a limit, well, first notice that this thing is just 0. So I can just rewrite it like this. And now I can take the limit so limit of 0 is just 0, so that's not surprising. And we'll have a limit of cosine squared 2x over 3 minus 2x. And on the right here, we have limit. So this is really a small number divided by a large number. And we know by now that this goes to 0. So we can now see that our function is bounded by two functions that go to 0. So the limits are going to 0, so therefore we say our limit as x approaches x approaches infinity, cosine squared 2x over 3 minus 2x also has to go to 0. Okay. Let's look at another cosine. I have limit as x approaches 0 from the left of x cubed times cosine of 2 over x. Okay, so we know at x equals 0, cosine of 2 over x does not exist, since we can never divide by 0. We know that cosine 2 over x oscillates between -1 and 1. And so so that takes care of this part right here. So all I need now is to multiply by x cubed. So if I multiply by x cubed, I get negative x cubed less than or equal to x cubed cosine 2 over x less than or equal to 1. Less than or equal to x cubed, sorry. And here I made a mistake on purpose. I'm looking for when x is approaching 0 from the left. So x here has to be negative, since I'm looking at negative values to the left of 0. So my inequality has to switch. So it has to be greater than or equal to 0 and greater than or equal to 0. Since negative x cubed now is positive, since x is negative, and x cubed is negative, since x is negative. Okay, so I have that. The next thing is I'm going to be taking the limit as x approaches 0. So here I can do approaching 0 from the left. Doesn't really matter because x cubed is a continuous function. So the left-hand limit and the right-hand limit are both 0. So it doesn't really matter if I approach 0 from the left or not, but for the sake of this problem, let's do it. I have limit as x approaches 0 of negative x cubed greater than or equal to 0 of greater than or equal to limit x approaches 0 from the left of x cubed, let's rewrite that, x cubed cosine 2 over x, and that's greater than or equal to limit as x approaches 0 from the left of x cubed. So obviously the two bounds here are going to be 0, since we know the limit of x cubed is 0, or negative x cubed. So that'll be negative x cubed. That's also 0. So we have 0 greater than or equal to limit as x approaches 0 from the left of x cubed cosine 2 over x greater than or equal to 0. So I'm bounded between two limits that are going to 0. So we say that the limit as x approaches 0 from the left of x cubed cosine 2x is also 0.